Welcome to Study Loop.
So for this one, we have a cube. It's made of solid copper. It's 2 centimeters cubed, so 2 cubic centimeters, and it's at standard atmospheric pressure. It's heated from 20 to 90 degrees Celsius. We want to know the change in volume, which is going to be the starting volume of 0.02 meters cubed times the specific heat of the actually, this isn't the specific heat. This is the thermal expansion coefficient. I'm sorry. Thermal expansion coefficient of copper, 5.1. This 70 degrees Celsius. That gives us a change in volume of 2.86 times 10 to the negative eighth cubic meters. Next thing we want to know is the amount of work done by the cube. So that's just the standard atmospheric pressure multiplied by the change in volume we just calculated. So 1.01 times 10 to the fifth power pascals multiplied by 2.86 negative eighth meters. And that gives us work of 2.88 times 10 to the negative third power in joules. And then we want to calculate the amount of heat added to the cube, which we can use this formula for. This is the density multiplied by the initial volume. This is S, it should say C. It's the specific heat of the copper. So density is 8.9 times 10 to the third. Volume is 0.02 cubed. Specific heat is 386, and the change in temperature is 70 degrees. And that gives us 1,924 joules. Then we're asked to calculate the change in internal temperature, which is just the change in heat, or it's the heat minus the change in temperature. I guess I wrote that wrong. I was a little confused there for a second. Temperature is not a unit of energy. Heat, work, those are units of energy. Anyway, so we have 1924 minus the work we calculated at 2.88 times 10 to the negative 3. And that gives us, when rounded, the same number, 1924 joules. And as for the last bit, wants to know if there's any specific or any substantial difference between the specific heats at constant pressure and at constant volume for copper. And we can say no, since the work done is much, much less than the change in heat.